Okay, in today's video, as you can see, we are going to be using one of the PhET interactive simulations to show you how to investigate how series and parallel circuits work. Now, before we get started, please don't forget to subscribe to my channel, Step-by-Step Science, and get all my excellent physics, chemistry, and math videos. When I look at my YouTube channel, I see that more than 90% of the people who watch my videos have not subscribed. Come on, support my channel. Subscribe, please. You should subscribe, click the notifications bell, give me a thumbs up, leave me a comment, and share this video. And I have made a bunch of other teaching and learning materials, which you can find at my Teachers Pay Teachers website, whether you're looking for example problems, whether you're looking for notes, whether you're looking for worksheets, whether you're looking, for example, for, as you can see here, this simulation, which you can use right here with this PhET product that I've made. You can find the link in the description below. Okay, now let's get started with the simulation. This is a simulation that we're going to use. This is from PhET Interactive Simulations. Check out their website. They have tons of great simulations for all kinds of math and science projects. And we're going to be using this DC construction kit, Circuit Construction Kit DC. This is an HTML5 simulation, which means there's nothing to download, there's nothing to install, there's nothing to buy, nothing to subscribe. It's all free. It works great. You get great results. Support PhET. I'm going to start here with the intro window. It doesn't matter whether you use a lab window or the intro window. The lab window has some extra stuff. We're going to use the intro window just like that. And this is the desktop or the palette or the screen that you get. And you can see over here, we have all the circuit elements. And you can click down here. You have some additional stuff, coins, dollar bills, fuses. You can even have a hand. Don't stick your hand in the circuit. And there's a dog. I don't know why anybody would want to use a dog in the circuit, but you know, that's the way it is. And an eraser, all that kind of stuff. And then over here we have some controls, which I'll show you. We have a voltmeter, ammeter, and we have our circuit symbols that we can depict in different ways. Now I'm just going to go through how you build the circuits and how you use this simulation. I have a bunch of other videos which you can link to in the upper right hand corner where I go through how series and parallel circuits work, but I'm just going to show you in this video how you use this PhET simulation. So you can take a battery, and the first thing we're going to do is we're going to build a series circuit. Now you can just drag everything on and it connects in these circles, and you can extend these and make them longer, and excuse me, and you can also squeeze them together and make them shorter. But we're going to build a series circuit with a simple bulb, and we have wires like this. And when we build a series circuit, we build all of our circuits, we like to use straight lines and right angles so it looks nice and neat. Okay, you don't want to have a bunch of stuff all over the place. You don't want to have your wires crossing, and not wires crossing, but you know, it should look nice. Make it nice and neat like that. And you can see we can do this, and then we can do that. And then we can drag a bulb over here, and you can turn the bulb sideways by circling one of the circles, and we can put it into our circuit. Now, you have to remember when you connect the bulb, that the bulb has to be connected. It has two connections. It has one here, and one there. You have to put one wire on one and one on the other. You put them both in the same place, you get a short circuit. The electricity doesn't go through the bulb doesn't light, and the battery lights on fire, and that's not a good thing. But you can click right here, and then you can click the scissors. It breaks everything apart, and you can put it back in there like that, and you can turn that like that, and then you bring the wire down, and there you go. You get a nice circuit just like that. Okay? And then the nice thing is you can take your voltmeter like this, and you can drag your voltmeter onto the screen, and you can measure the voltage difference across the different circuit elements. So maybe your teacher wants you first to measure the voltage across the battery. You can see that's 9 volts, and that means that that's a 9-volt battery. And then maybe your teacher wants you to measure the voltage across the bulb or some other resistor like that, and you do that, and that's minus 9 volts because the voltage is decreasing across there, the potential difference. And then maybe your teacher wants you to measure the current, and then you take the current meter out, and you can put it anywhere in the circuit where you want to measure the current. Now, you should know in series circuits that doesn't matter where you put it, the current is always going to be the same. So you can see that you have the current as 0.90 amperes, and the voltage at the bulb is 9 volts, and the voltage at the battery was also 9 volts. You want to put the leads for the voltmeter on either side of the element. If you put them on the same side, you just get 0. Where this current meter is nice, you can just put it anywhere you want in the circuit, and then you can measure the current just like that. Okay, now over here you can see we can show the current as electrons, or we can show conventional current depending on how your teacher wants you to see. The conventional current obviously goes in the opposite direction. Most people, when they're starting out, they want to see the flow of the electrons because that's what's actually flowing. And we have a labels. The labels is just the labels for these elements over here. And the values, you can click on there. You can see that that's actually a 9-volt battery. And that's a 10 ohm resistor. That's omega. That's the symbol for ohms for resistance. And then you could also switch from the realistic view to the circuit diagram view. Most people, I think it's a little better when you're starting out to leave it as the real view like that. Okay, now that's a series circuit with one bulb, and we're going to put another bulb in. Oh, the other thing I want to do is show you can put this, open this up like that, and we're going to put a switch in here. It's good to have a switch, so we can put a switch like this. Oopsie daisy, carry a switch up there like that. You can bring that over like that, and you bring that back up there. And then you can control the circuit, open and close the circuit with a switch. No resistance across the circuit. I like to leave the values off. And now what we're going to do is we're going to add another bulb. So I have 2 bulbs in series. I click here, I click the scissors, I'm going to move this over here like this. I'm going to grab another bulb like this, which I'll connect here, and then I'm going to bring this one over here. I think I can just drag this over there and connect it like that. And you can say I can open and close the switch, and then that circuit lights like that. Now we can take these and we can measure the voltage across each of the individual bulbs like that. Okay, maybe you need to write down for each of the individual, and now again we can measure the current through the circuit like that. That's a series circuit with 2 bulbs in series. And now we can do the same thing, and we can add another bulb, because a lot of times you want to have 1, 2, and 3, and then you see the pattern. You're supposed to see the pattern about how the circuits work with bulbs in series, and usually we do 1, and then we do 2, and then we do 3, and you can see like that. Now we have 3 bulbs. And you can measure, once again, the voltage across the battery first, and then maybe you want to measure the voltage across the bulbs, all 3 bulbs. You can do all 3 bulbs like that. Okay, if you want to measure, I'm going to try not show you all the answers, so you have to figure it out yourself a little bit. You can do that. If you close the switch, then you'll get the voltage, and you can also measure the current regardless of where you are in the circuit like that. So that is 3 bulbs in series. Now you could add more bulbs, and you'll get the corresponding examples and the corresponding answers for 3 bulbs. Okay? Now, what we're going to do now is we're going to do parallel circuits. So that was 3 bulbs in series. Now this is going to be 3 bulbs in parallel. I'm just going to get rid of some of this stuff so that we can kind of start almost new again. And let's see, I just want to get rid of this bulb. And then I'm going to get rid of this wire, I think. And then I'm going to put this over here. Now, when we talk about bulbs in parallel, okay, the circuit that we're going to draw, if you're starting from the beginning, it's just going to look similar to the bulb in series, okay? So that's basically 1 bulb in parallel. I would say that's where you start. But now we're going to add another bulb in parallel. So you don't have to open the switch. I like to open the switch. I'm going to put another bulb that's in parallel. And when you put a bulb in parallel, we call it a parallel circuit because it should look like it's in parallel. There are a couple different ways to draw it. I think this is maybe the most common, the different ways to build it. And then, but they should just look like they're parallel because it's a parallel circuit. That's why it's called a parallel circuit, because it looks like it's parallel. So we can turn this like this, grab that and bring that. And now we have 2 bulbs, and those bulbs are in parallel. They don't have to be exactly in the same place, somewhere like that. And then you can close the switch. And now once again, maybe your teacher wants you to measure the voltage across the battery. Well, it's still a 9-volt battery. And then maybe you're supposed to measure the voltage across each of the bulbs, like that, each of the individual bulbs. And then maybe you're supposed to find the current through the battery. And then maybe you're supposed to find the current through each of the bulbs like that, each of the individual bulbs. And then maybe you should notice something about the brightness of the bulbs. Now, just like we did last time, we had 2 bulbs in parallel, in series. Now we're going to add a third. Like I said, I'd like to open this. Bring this over here. And you can see you can do this very easily. Get the current meter out of the way. Add another bulb It really goes nice and quick. You get nice results. Everything works out the way it's supposed to. You get consistent results. You can check everything over and over again. And let's see, we do that. And then we get our last bulb, turn that like that. And then if I close the switch, it'll all run. And once again, I can measure, first of all, the voltage across the battery, then the voltage across each of the 3 bulbs. Then I can measure the current through the battery. And then I could also measure the current through each of the bulbs. And then I should notice something about the brightness like that. And really, in just a few minutes, 10 or 15 or 20 minutes, you can really investigate series and parallel circuits and get a good understanding for how the voltage, the current, the brightness, the resistance of a circuit changes when you add bulbs in series and when you add bulbs in parallel. Okay, I highly recommend the PhET simulations. They're great. Check them out. Thank you so much for watching this video. I hope you found it helpful. If you did, please do all of the following 4 things. Subscribe to my channel. Click the notifications bell. Give me a thumbs up. Leave me a comment. I guess there's 5 things. Share this video. Sharing is caring. Show your friends how much you care and share this video with them. Thank you so much for watching. We'll see you in the next video.